Hello there. I wanted to go over really quickly a little bit more on the very end of the chapter or the section about quadratic functions and their properties. We had worked through example 6 where we were graphing a quadratic function using its vertex, axis, and intercepts. And we wanted to talk about if we have the vertex, let's say hk, and one additional point on the graph of a quadratic function where f of x is equal to ax squared plus bx plus c, with a not equal to 0. So if you know those 2 points, then the vertex form of f is going to be equal to f of x is equal to a times x minus h squared, that whole quantity, plus k. And that can be used to obtain the quadratic function. So if we do an example, let's say we have a quadratic function, we're given its vertex and one other point. Here we're going to say that we have a quadratic function whose graph has a vertex of -2, 5, and it passes through the point 0, -7. So here we know that hk is equal to -2, 5. And we have some point P that's on the graph of the quadratic function that is at 0, -7. Keep in mind that that means if I have a function f, then f of 0, when x equals 0, then f of 0 is equal to -7. So let's go ahead and use the vertex form of the function, and we can find the quadratic equation. So we have f of x is equal to a times x minus, and here we're going to use the h value, -2, all of that squared, plus 5, which is our k value, which is equal to a times x plus 2 squared plus 5. So that's our f of x, the general equation to start with. Now we just said that we know f of 0 is equal to -7 from the point that we know is on our graph. So we can substitute in f of 0 is equal to a times 0 plus 2 squared plus 5. 0 plus 2 is 2, and 2 squared is 4, so I have f of 0 is equal to 4a plus 5. And that's equal to -7. We know that from over here, okay? So if we solve now for a, we have 4a plus 5 is equal to -7. If we subtract 5 from both sides, then we have 4a is equal to -12. -7 plus -5 is -12. And dividing both sides by 4, we find that a equals -3. So if I switch colors quick here, we can substitute that back in, and we can say f of x is equal to -3 times x minus, or I'm sorry, plus 2, because minus and -2 squared, plus 5. So we could leave it like that if we want the function to be in vertex form. If we want to put it into the regular quadratic function form, we can first FOIL the x plus 2 squared part, and we'll get x squared plus 4x plus 4. So we have -3 times that quantity, plus a 5 out here still. If we distribute our -3, we have -3x squared minus 12x minus 12 plus 5. And finally, if we combine our like terms, our constants out there at the end, we have a function that's -3x squared minus 12x minus 7. And this would be the function that we would be looking for. Hopefully that is helpful, and you can see it both in the vertex form up here at the top, and you can see it in our regular ax squared plus bx plus c form down at the bottom there. All right. So one last section, we want to note that if A is greater than 0, keep in mind that means that we're concave up. It's positive, so it's happy. The vertex is the max, or the minimum point, minimum point. On the parabola, since the parabola is concave up, it's this point right here is where our vertex is. This means that f of b over negative 2a is going to be the minimum value of f, and it's going to happen at x equals b over negative 2a. One note that I'd like to clarify, this is going to be also, we could also say this is the absolute minimum, because there's no point on that function that can be lower than that. So if I have a function that has a vertex there with an a greater than 0, then it's an absolute minimum. If a is less than 0, remember we're concave down, so our vertex is here. So the vertex is the maximum point on the parabola, and that means that f of b over negative 2a is going to be the maximum value of f, and again, that's at x is equal to b over negative 2a. Similarly here, this is an absolute min, or max, sorry, this is an absolute max, I'm looking above it, for that particular function or parabola. So let's take a look at example 8 here. It's the last example in this section. Determine whether the quadratic function f of x equals negative x squared plus 4x plus 5 has a maximum or minimum value, and then find the maximum or minimum value. So if we rewrite this, we can say it's f of x equals negative 1 times x squared plus 4x plus 5. So that means that a equals negative 1, which is definitely less than 0. So that means that we're concave down, and so the vertex is a maximum. So we have a maximum here. Now to find the maximum value, remember it occurs at x equals b over negative 2a. So let's find that. Our max is at x equals negative b over 2a, which is going to be negative 4 over 2 times negative 1, which is going to be negative 4 over negative 2, which is just 2. So our max happens at x equals 2, and the maximum value is f of 2, which is going to be negative 2 squared plus 4 times 2 plus 5, which is going to be equal to negative 4 plus 8 plus 5, which should give us a maximum value of 9 for f of 2. So we can say that we have a maximum at f of 2 equal to 9, or you can say the maximum is at 2, 9 at that point. So you can say that either way. Hopefully this is helpful. This finishes out section 4.3, and we'll move on to 4.4, which is more applications and building quadratic models from verbal descriptions. And that will be really helpful for the concept check that's coming up. So let me know if you have any questions. Like I said, this one's pretty short. So I'm wrapping it up for now. Thanks. Bye.